Hi everybody, welcome to topic number 32, solving quadratic equations by completing the square. In this video, we'll show you how to use the square root property to solve quadratic equations, which will lead us to solve quadratic equations by completing the square, and we'll solve quadratic equations and some problem solving. So far we've showed quadratic equations using the factoring methods and the quadratic formula. Now we'll practice another method called completing the square. In order to do this, we're going to understand the square root property. So the square root property works whereas if a squared is equal to b, then a by itself is plus or minus square root of b. Now I want to make sure I break down this part where it says a is plus or minus square root of b. Whenever we think of square root of 36, for example, we think that the answer is 6 because 6 times 6 is 36. However, we also have to realize that negative 6 times negative 6 also equals 36. So when we look at a square root, we have both a positive and a negative answer, which is denoted by this plus or minus. Whenever you see plus or minus, it tells me we have two solutions. One of the solutions is positive 6, and one of the solutions is negative 6. So anytime we take the square root of a number, we get that plus or minus. We see that a lot when we did the quadratic formula. Whenever we did the quadratic formula, which was this, negative b squared plus or minus the square root of b squared minus 4ac over 2a, we see that plus or minus there. That plus or minus is because we're taking this square root right here. So what we're going to do is when we go through and square root from now on, we're going to assume that there could be both a positive and a negative answer. Let's show you here. So use the square root property to solve each quadratic equation. We have x squared equals 50. Our job is to get x by itself. So we're going to square root both sides. When I square root the squared, it leaves me with x. Here, I'm going to have square root of 50, but now there could be both a positive and a negative answer, so it's positive negative square root of 50. Now we're going to look and see if we can break down 50, and we know 50 is 2 times 25, where 2 is prime, and 25 is 5 times 5. So I've got a pair of 5s and a 2, so the square root of 50 becomes 5 square root of 2 with the plus or minus on the outside. So again, this tells me my two solutions are positive and negative 5 square root of 2. So that means one of my solutions is positive 5 square root of 2, and the other one of my solutions is negative 5 square root of 2. B, we're going to go through and we're going to unwind and solve for x squared. So we've got to work to get x squared by itself. We're going to move this negative 14 to the other side by adding it. So now we have 2x squared equals 14. We'll divide both sides by 2. We have x squared equals 7. In order to get rid of the squared, we will square root, but whatever we do to one side, we'll do the other. So now this will become x equals plus or minus the square root of 7. And since 7 is prime, it can't break down any further. This would be my final answer. Again, this represents we have an answer of positive square root of 7. We have an answer of negative square root of 7. Now in this problem, we have the entire binomial wrapped around the squared, so we have to get rid of the squared first. So we're going to undo it by square rooting. We remember that when we square root a squared, it cancels out and leaves us with the inside. So this is now x plus 1. And this will be square root of 12, but it will be plus or minus the square root of 12. And again, we're going to look and see, can we break down 12? 12 will become 4 and 3, and 4 becomes 2 and 2. So really, this is x plus 1 equals 2 square root of 3 with a plus or minus in front of it. Now my job is to get x by itself. I have a positive 1 here. I'm going to subtract it to the other side. I have x equals, this negative 1 will not combine with this 2 because this 2 is attached to the square root of 3. So we're going to write it negative 1 plus or minus 2 square root of 3, and that will be our final answer. We typically like to write the plus or minus sign at the end, and we'll put the real part first. So this tells me, again, there's two answers that I can give. I could say negative 1 plus 2 square root of 3, and I could say negative 1 minus 2 square root of 3, and both of those would be answered. But to represent it the shorthand, we use that plus or minus. We'll do the same thing for d. We have a squared here. We're going to get rid of it. So we're going to square root both sides. Over here it leaves me with the inside. Now remember, we can't take the square root of a negative, but we can bring the negative out and it will become I. So this is the square root of I to the 16th. Still again with the plus or minus because we're square rooting. And the square root of 16 is 4. So this is plus or minus 4i. And now our job is to get x by itself. I'm going to add 5 to both sides. I have 2x equals, I'm going to put the 5 first because we want the I part last. So 5 plus 4i. And then we're going to divide everything by 2. So this would become 5 plus or minus 4i over 2, which we can really break that down as 5 over 2 plus or minus 4i over 2. And while 5 over 2 doesn't reduce, the 4 divided by 2 will make this a 2i. So this will be our final answer. And again, we have the plus or minus here. So that's telling me one of my solutions is 5 over 2 plus 2i. And then the other solution, which I'll write over here, is 5 over 2 minus 2i. Now, plus or minus indicates we're going to have two different solutions in our answer. If we write a quadratic equation so that one side is the square of the binomial, we can solve by using the square root property. To write the square root binomial, we write perfect square trinomials. So here we have these perfect square trinomials. So if you think back to when we did a equals 1, we used to take this and say, well, what multiplies to 16 but adds to 8? And we would get the same number, 4 and 4. And the way we would represent that is in factored form is the same thing squared. So all of these are perfect squared trinomials that are in factored form. We can make these by doing what's called completing the square. So we complete the square to make these perfect square trinomials so that they can become in this factored form of something plus or minus something squared, because now we know how to use the square root property to get rid of it. In order to do this, the constant term of the trinomial is the square of half the coefficient of the b term. So to do the completing the square process, we're just going to take the b term and divide it by 2, and we will square it, and that will go through and complete the square. And when we complete the square, we'll put it on both the left and the right side of the problem. Here are our steps for completing the square. The first thing we have to know is that the leading coefficient must be 1. If it's not, we'll divide both sides by that number. We'll show you a problem later on where the leading coefficient isn't 1 and what we can do. We want to get all the variables on one side and the constant term on the other. So we want one side with nothing but the variable, and the other side will have anything that doesn't have a variable with it. We'll complete the square by creating a perfect square trinomial. We'll take half of the middle coefficient, square it, and add it to both sides. For this, again, when we think of ax squared plus bx plus c, that middle term is always the b part. It's always the part that has just the x coefficient. We'll then factor it, and if we did it correctly, it should end up as a perfect square trinomial, and then we'll use the square root property to finish solving. Let's show you a couple examples. So on this first one over here, we've already done one of the steps. We have all the variables on the left side, and we have the constant on the right. And because there's no number in front of here, a is already equal to 1, so we don't need to do anything with it. And b is equal to 4, so this is my b term. So in order to complete the square, we're going to take the b term and divide it by 2, and then we're going to square that number. So in this case, we're going to take 4 and divide it by 2, which is 2, and then we'll square 2, and with that, we get 4. This 4 is going to be added to both the left and the right side of the equation. So we're going to go through, it'll be r squared plus 4r, and then over here we will have plus 4 equals 3 plus 4. So again, notice I took the original equation and all I did was add the part where we complete the square. To finish solving this, we'll take this side and combine it to 7. And now this is my perfect square trinomial. So if I did this correctly, we should only be looking for one number. I'm looking for something that multiplies to 4, but also adds to 4. And if it's one number, the only thing that does that is 2 and 2. So we can rewrite this as r plus 2 squared, because we have two 2's. Now this is like the square root property. We could take this and get it by itself and solve for r. To get rid of the squared, we will square root. This cancels it out. It leaves me with r plus 2 on the left. And we think this is square root of 7, but remember, now that we're square rooting, it's going to be plus or minus here. So this is really plus or minus square root of 7. My job is to get r by itself. I subtract 2. I now have r equals, we'll start with this part first, negative 2 plus or minus square root of 7. And this would be my final answer. So again, it tells me I have two solutions. One of them is negative 2 plus square root of 7, and the other solution is negative 2 minus square root of 7. You could put it in as either the separate solutions, or you can go ahead and put in the plus or minus when you do it in math lab. Either one, it will take the answer. On B, notice now I don't have the constant over here. So I'm going to move the constant over here before I begin completing the square. I always want the left side to be nothing but variables and the right side to be the constant. So now I'm going to identify the B term. The B term in this case is negative 7. So I need to take half of negative 7, which is just negative 7 over 2, and I need to square it. When I square a fraction, I square both parts. So negative 7 squared is 49, and 2 squared is 4. So this now becomes x squared minus 7x, and then we'll do plus 49 over 4 equals 1 plus 49 over 4. So again, the 49 over 4 is the result of completing the square when I took the b term and I divided it by 2 and I squared it. On the right side, we will go through and add this. We'll do 1 plus 49 over 4. We'll change this to 4 over 4 to make 1 plus 49 over 4. That makes this 53 over 4. And over here, we'll complete the square. And if you notice, we'll kind of go back to this problem and show you the little trick. When we went through and did the perfect trinomials, we got 2 and 2, but if you noticed, the 2 we saw before, because after we divided by 2, we had a 2. So really, this number that goes inside should be whatever we get after we divide by 2. That's important in this case. When we divided it by 2, we got negative 7 over 2. So this will actually factor to be x minus 7 over 2 squared. So whatever we get after we divide by 2 should be the term that goes into here. Now let's use the square root property to get rid of it. I need to square root both sides in order to do this. Here the square root and the squared cancel out and leave me with x minus 7 over 2. And here I'm square rooting both parts, so the square root of 53 over the square root of 4. And we're going to change this bottom part because we know that the square root of 4 is simply equal to 2. Now another thing, we took a square root, so this has to be plus or minus. Every time we do it, we have to put that plus or minus after we square root. Now I'm going to get x by itself. I'm going to add 7 over 2 to both sides. And again, even though this has a 2 and this has a 2, we're not going to add it because of this plus or minus. So I'm just going to say the answer is x equals 7 over 2 plus or minus the square root of 53 over 2. I don't want to go through and add it because I would need to get both solutions in order to do that. Also, there's nothing really to add we could do because this is a square root. So we will leave this as our final answer. Let's show you one last problem. So in this problem, now we have a equals 2. A is not equal to 1. So we're going to show you what to do if that happens. The first thing we're going to do is we're going to move the non-variable to the right side. So I have 2x squared minus 8x equals negative 3. Now that I've done that, I have to get this front term to equal 1. So I'm going to factor out the a term. So I'm going to take a GCF, and I'm going to factor out a 2. And when I do that, That's going to leave me with x squared minus 4x. And I'm not going to touch this side over here. We'll show you what we're going to do with this side later on when we get back over there. But for now, all I did was factor out a 2 from the left side. And now I'm going to do the completing the square process. This negative 4 is the b term. So I'm going to take negative 4 and divide it by 2. And I get negative 2. And then negative 2 squared is positive 4. So now this becomes 2x squared minus 4x. And now we will go through and add the 4 we got from completing the square equals negative 3 plus the 4 we had. Now remember, this is where the 2 comes into handy. Because we factored out a 2 over here, we're going to have to take this over here, and we're going to also multiply it by 2. So, very important here. Whatever we factor out here, that's what we multiply here. We just multiply by whatever a is when we get to this step. Okay? So again, if you factor out something here, when we finish completing the square, that's what you're going to multiply it by here. So it's basically saying we have 2 4s here. We'll finish this side, negative 3 plus 8. This ends up becoming a 5. Here we ignore the 2. This again is a perfect square trinomial. The number we got after we divided it by 2 is negative 2. So this will be x minus 2 squared with a 2 on the outside. And then here we can just combine, and we are left with 2 times x minus 2 squared equals 5. And now we can use the square root property to start to get x by itself. I have 2 times this whole thing, so I'm going to divide everything by 2. So now I have x minus 2 squared equals 5 over 2. I need to square root to get rid of the squared, which means I need to square root this side. So this is x minus 2 equals positive or negative square root of 5 over square root of 2. Now, we can't leave the denominator as a square root, so we're going to rationalize it. And if you remember how to rationalize it, we're going to multiply both parts by the same on the bottom. So this is x minus 2 equals plus or minus 5 times 2 is square root of 10. Square root of 2 times square root of 2. Remember, if you multiply a square root by itself, the square root goes away. So now I have plus or minus square root of 10 over 2. I need to get x by itself. It says negative 2 here. So I'm going to add 2 to the other side. And I have x equals 2 plus or minus square root of 10 over 2. And again, we'll leave that as our final answer. Again, remember this represents 2 solutions. We have 2 plus square root of 10 over 2 as one solution. And we have 2 minus square root of 10 over 2 as the other solution. Again, when you get to Math Lab, you can either put them in separately like this, or you could put in the plus or minus, and that will be sufficient. So again, remember, when we go through and we square root, the biggest thing is making sure we have 2 solutions now when we do that plus or minus.